Solve the quadratic equation 1 minus 3i z squared minus 2 plus I z plus I equals to 0, giving answer in the form of x plus iy when x and y are real. To solve this quadratic equation, we can use the quadratic formula by putting the values of a, b, c here. Or we can simplify the expression first by removing the complex number in front of z squared. I will do that method. So all terms I will multiply by the conjugate of 1 minus 3i. So I multiply by 1 plus 3i minus 1 plus 3i, 2 plus I, z, plus 1 plus 3i, I equals to 0. And then in here I will have 1 square plus 3 square, z square minus 2 minus 3, and then 1 plus 6 plus 7i, z plus I minus 3 equals to 0. Don't forget, in here we have to remember z times c conjugate is x squared plus y squared, and then I squared is equals to negative 1. So we can simplify 10z squared minus negative 1 plus 7i z plus I minus 3 equals to 0. So this is A, B, and C. We can use the quadratic formula. So z equals to minus b, negative 1 plus 7i, plus minus the root of minus 1 plus 7i squared minus 4ac over 2a. So I have negative 1 plus 7z plus minus the root of complex number square is equals to x squared plus y squared. Okay, we can expand this x plus iy squared. So this will be x squared minus y squared plus 2xyi. So I can use x squared minus y squared. So 1 minus 7 squared, and then plus 2 negative 1, and then 7i. Minus 40i plus 120 over 20. So minus 1 plus 7i plus minus the root of 1 minus 49 is equals to minus 48. So 72 minus 54i over 20. Now we have to find the square root of 72 minus 54i. So again, z squared equals to 72 minus 54i. So that means x squared minus y squared will be equals to the real part, 72, and 2xy equals to the imaginary part, negative 54. So from here, I can make y equals to negative 27 over x. And then I replace the first equation, so it's x squared minus negative 27 over x squared equals to 72. So x squared minus 729 over x squared equals to 72. So x4 minus 729 equals to 72x squared So x4 minus 72 x squared minus 729 equals to 0. And here we can factorize x squared, and then, so this is minus 81, and then plus 9. In this case, we have x squared equals to 81, so x will be x equals to 9 or x equals to negative 9. In here, x squared equals to negative 9, so this one is not possible because the complex number z should be, x and y in complex number z should be real numbers. And then I can find the y using this. So y equals to negative 3 or y equals to 3. So that means the z will be 9 minus 3i, or z equals to negative 9 plus 3i. So I can write here negative 1 plus 7i plus minus the root of the complex number, which is 9 minus 3i over 20. So I can use negative 1 plus 7i plus 9 minus 3i over 20, or negative 1 plus 7i minus 9 plus 3i over 20. So 8 minus 4i over 20, or negative 10 plus 10 over 20i. So 2 over 5 plus, plus 2, 1 over 5i, or z can be negative half plus half I. So that's it. On a sketch of an organ diagram, select the region whose point represent complex number z, satisfying the inequalities. Okay, this one is z plus, I make it minus, negative 2 plus 0i. So that means I can find a circle center negative 2, 0 here, and then the radius is 2. So here, negative 4, negative 2. Okay. And then should be smaller than, so that means it's inside the circle. But we have to draw also imaginary z greater than 1. So imaginary z greater than 1 is this. So find the region smaller than 2. That means inside the circle, and greater than 1. So here. Find the greatest value of argument z for point in the shaded region. So in here, if you want to find the argument z here, that means z minus 0. So it starts from 0, 0, and then find the argument z, the maximum. And the maximum in here will be in this point. I can draw the line, this, and this will be the argument z. And we know that from the circle, we can find the triangle. We know that this is 2, yeah, the radius is 2, and the height will be 1. So we have a right angle triangle. This is 2, this is 1. So we can find the angle in here. So that means I can find the angle of sine theta equals to 1 over 2. So theta is 30 degrees. Now, we move to the other triangle. So I have another triangle, yeah, constructed by the radius 2. And this is 30 degree. So this one is 150 degree. And this is 2. So this is an isosceles triangle. So that means the angle in here will be 180 minus 150 divided by 2, which is 15 degree. And that means we can find the angle of the argument. Yeah, the argument z will be here. So this is argument z. And we have to express it in the radian. So the argument z in here is pi minus 15. So it's 15 is pi 100 over 180. So equals to 11 over 12 pi radian. 3. The complex number u is given by find 2 square roots of u, giving your answer in the form of this. Okay, so u squared equals to 10 minus 4 root 6 I. So again, if this is x plus iy, 10 minus 4 root 6 I, so that means x squared minus y squared equals to the real part, and 2xy equals to the imaginary part. So from here, y equals to minus 2 root 6 over x. And then I can replace the equation. Negative 2 root 6 over x squared equals to 10. So x squared minus 4 times 6. 24 over x squared equals to 10. So x squared minus 24 over x squared minus 10 equals to 0. So x4 minus 10x squared minus 24 equals to 0. We can factorize x squared minus 12 plus 2. So x squared will be equals to 12. X will be equals to 2 root 3 or negative 2 root 3. And in here, x squared equals to negative 2, so this is not possible. Yeah, because x and y should be real number. So in here, y should be equals to, I can put it to the here, it's negative root 2 or root 2. So the roots are u equals to 2 square root 3 minus root 2i or u equals to minus 2 root 3 plus root 2i. On the sketch of an organ diagram, set the region whose point represents complex number z satisfying the inequalities. So this is z minus 1 plus I, smaller than or equals to 1. And this is z minus 1 plus 0i. So we can draw it. This is the circle center negative 1 and 1. So negative 1, negative 2, negative 3, 1, 2, 3. So negative 1 and 1. The radius will be 1. So it will be like this. And then this one is argument z minus 1. So it's from 1, 0, 1, 0. And then smaller than 3 over 4 pi. So 3 over 4 pi is the straight line with the gradient of negative 1. Yeah? Tangent 3 over 4 pi is equals to negative 1. So it is a line with gradient of negative 1. So I can draw this negative 1, so it means it will pass through the 1 here, like this. Yeah, this is the argument Z. And then we have to set the area inside the circle and smaller than 3 over 4. So that means it will be in this region. Find the complex number Z satisfying the equation denotes by conjugate of C. So in here, I can cancel the denominator by multiplying it with the Z conjugates. So Z times Z conjugates plus IZ minus 2Z conjugates equals to 0. And then I can replace by Z equals to X plus IY and Z conjugate X minus IY. So I will have X plus IY, X minus IY, plus I, X plus IY, minus 2X minus IY. So here I have X squared plus Y squared plus xi minus y minus 2x plus 2iy. I can collect the real x squared plus y squared minus 2x minus y equals to, this is the real part, and then plus x plus 2y I equals to 0. So from here, I can have x squared plus y squared minus 2x minus y equals to 0, or x plus 2y equals to 0. So x here is equals to negative 2y. So negative 2y squared plus y squared minus 2x negative 2y minus y equals to 0. So 4y squared plus y squared plus 4y minus y. So 5y squared plus 3y equals to 0, y, 5y plus 3, y can be 0, or y can be negative 3 over 5. And then x is 0, and x is negative 2y, so 6 over 5. So in here, I can find that the only solution is z equals to 6 over 5 minus 3 over 5. On a single organ diagram, sketch the loci given by the equation. This is a circle, center 0 plus 2i, and this is 0 minus z minus 0. So I can draw circle z minus 2i, so 0, 1, 2, 3, 4. So center here, radius 2, like this, and then z from 0, imaginary part, yeah. So imaginary 3 is here. Okay, so we have two intersections. In the first quadrant, the two loci intersect at point P. Find the exact argument of the complex number represented by P. In the first quadrant, the two loci intersect at the point P. So this is P. Find the exact argument. Okay, so this one argument Z is this. As we know that this is 3, and we have the triangle here. So this is 2, and this is 2. So from here, we can find the angle. Okay, so again, we have two triangles. So this is 2, this is 2, this is 1, and this is, we don't know yet. So we can find theta first here. So the theta will be cos theta equals to 1 over 2. So theta will be equals to 60 degree, or in the radian, it's pi over 3. So that means this is right angle. So we can find the angle here. It's 2 over 3 pi. And then we can use the isosceles triangle again to find the angle here. So the angle here is 180 or pi minus 2 over 3 pi, and then divided by 2. So it's 1 over 6 pi. So that means the argument z here, the argument z will be equals to pi over 2 minus 1 over 6 pi equals to 1 over 3 pi radian. Number 6. It is given that the complex number 1 plus root 3i is root of equation where k is a real constant. Write down another root of this equation. As we know that every complex root will come with the conjugate. So the other root will be negative 1 minus root 3i. because they come in pairs. Find the value of k and the third root of this equation. We have x cubed here, so that means maximum we will have 3 solutions. The first two are x minus 1 plus root 3i and x minus 1 minus root 3i. And we will find the third root, x minus with z3, so equals to 0. So we can expand this one first. So this is x squared. So minus -1 minus root 3i x minus -1 plus root 3i x, and then plus -1 plus root 3i, -1 minus root 3i. And all of this is multiplied by x minus the third root. Yeah. So we simplify this one first, x squared minus plus 1x plus 1x, so this is plus 2x plus root 3i minus root 3i. So okay, we can cancel the root 3i. And then from here, we can have plus 1 plus root 3i minus root 3i, so 0, and then minus 3i squared, so plus 3. And then we have x minus c3 equals to 0. So x squared plus 2x plus 4 multiplied by x minus c3 equals to 0. Now in here we will have x cubed or kx cubed plus 5x squared plus 10x plus 4 equals to 0. So if we can see, we can find the root should be in the terms of k in here, yeah, to get the k. So if we expand, we will have kx cubed plus 2kx squared plus 4kx minus the z3 will be a number. So the number should be, for example, I will have the letter a. Yeah. So ax squared plus minus 2a x minus 4a equals to 0. So I can combine kx cubed and then plus 2k minus a x squared plus 4k minus 2a x minus 4a equals to 0. So from here we can see that this should be equals to kx cubed plus 5x squared plus 10x plus 4 equals to 0. So from here we can say that a equals to -1. And if a is -1, so that means from here 2k minus a is equals to 5. So 2k equals to 4, k equals to 2. Yeah, we can check it here. 4 times 2 minus 2 times negative 1. So 8 plus 2 equals to 10. The same, yeah? So correct. So k will be equals to 2. So from here, we can construct the equation x squared plus 2x plus 4, 2x minus negative 1, so plus 1 equals to 0. So k equals to 2, and the other root will be x equals to, from here, 2x plus 1 equals to 0, so x equals to negative half. So the third root should be the real root, not complex root. Showing all necessary working, express the complex number in the form of r, e, I, theta. Give the value to correct to 3 significant figures. So we can simplify 2 plus 3i, 1 minus 2i, times 1 plus 2i, 1 plus 2i. So on the denominator, we will have 1 plus 4. And then on the numerator, 2 plus 3i, 1 plus 2i. So what's this? Over 5. So it's 2 minus 6. And then plus 4i plus 3i plus 7i. So equals to negative 4 plus 7i over 5. Minus 4 over 5 plus 7 over 5. And to express in the form of r, e, I, theta, so r equals to the Pythagoras, negative 5 over 4, over 4 over 5 squared, plus 7 over 5 squared. So it's 16 over 25 plus 49 over 25 rooted. So it's root of 65 over 5 in three significant figures, 1.61. And for the theta, we can use the argument z is tangent inverse 7 over 5 minus 4 over 5. So that means this is negative x, this is y. So it will be in the second quadrant. So the argument z will be this. So find the value of this in second quadrant. So it's tan inverse 1. This is radian, yeah. So radian tan inverse 7 over 4. So this is 1.0516. But since this is the second quadrant, so it's pi minus 1.0517. So equals to 2.09 radian. For B, on the Argand diagram, sketch the locus of point representing complex number Z, satisfying the equation Z minus 3 plus 2i equals to 1. So Z minus negative 3 minus 2i equals to 1. So the center will be 3 negative 2, radius equals to 1, 1, 2, 3, 1, 2. So 3, negative 2 here, and the radius will be 1. So this is negative 3. And then find the least value of Z modulus for point on this locus, giving your answer in exact form. So find the least value of Z. So that means the length from the 0, 0, yeah, the Z, to the circle, yeah, from 0, 0 to the circle. And it should be the least. The least is the shortest. So the shortest distance will be from here to the center. So this one. So this is the Z, and this line is the modulus of Z. So we have to find that value, yeah. We know that this is 2 and this is 3. We can find the length of, let's say this is O and C, and this is B. So OC will be equals to square root of 3 square plus 2 square equals to root of 9 plus 4, 13. And OB, which is the modulus C, the least value, will equals to the root 13 minus the radius. The radius is 1. So this is the final answer. So that's all for the discussion for the complex number compilations. Thank you for watching. Bye.